Hey, welcome to our video on how to use a Raspberry Pi Pico to control a servo motor. The servo motor we're going to be working with today is an SG90. Um, Now, to work with servos, you need to use pulse width modulation. If you don't know what pulse width modulation is, that's okay. We're going to use it today, but the way we're going to use it, you don't even really have to understand it really well. However, it would be beneficial if you wanted to understand more about how to control servo motors, to go watch some videos and some training on pulse width modulation. But I've got a simple library that will help us not have to worry so much about that. But I will show you the spec sheet. Does give us some good information about how to hook up the servo. So it shows the pins that come out of the servo and what each of those pins need to be connected to. So you should see three wires in the right hand side. You should see the three wires that are coming out of our servo over here and connected into our Pico here. And you see those colors are brown, or it might look black on the screen. It's a dark brown or black, red in the middle, and then an orange, or it looks kind of yellow to me. But the brown is the ground, and then the red, the middle one, is the positive, so the power line. So we can connect up to 6 volts as it shows here in our specifications, which is perfect because the Raspberry Pi has, 5-volt out. So that's right in between the 4.8 and 6 volts. So we're going to connect that to the 5-volt outs on the Raspberry Pi. And then this next one is the control pin, the PWM, or we sometimes call it the signal pin. So for those that do understand PWM, understand that we are going to control the servo by varying the duty cycle or the pulse width. Now, this specification sheet I found, and I'll link to it in the video description, I found that it's not 100% accurate. It shows a 1.5 pulse as being the middle, 9 and around 2 millisecond pulse being the 90-degree or center, and then around a 1 millisecond pulse being all the way to the other direction. So I found it to actually this one to be more correct, which is showing the pulse width being between 0.5 milliseconds and 2.4 milliseconds. But again, to do what we're going to do today, you don't even have to understand this too much, because I have built a library called the SG90. Now, I can't take credit for this. I will share a link to this where it is in GitHub. I have this out in GitHub so you can use it. And I actually borrowed it from, I pieced it together from different sources on the internet, and I have links to those different sources in the notes around this. And so feel free to use this if you want. Again, I'm not taking credit for all of it. I just kind of broke it down into parts that made it more understandable for me. But the main thing it is that we're going to use is there's this one function called duty cycle for angle. So we are going to import this library. We're going to save this library on our Pico. So that's the first thing you have to do is download this or copy this library. It's not very long. I actually have just as many comments as I do lines of code, but I wanted people who want to understand it to be able to read here and understand it. And honestly, I really did it for me because I wanted to better understand how it's working. So we're going to use this duty cycle for angle that is going to give us the actual duty cycle that we send in to control the pulse width modulation to tell it which angle to move to, 0, 90, 180. So those are the ranges we're going to use. So what you would do is go to the GitHub link that I have in the description, copy this, save it as sg90.py, and make sure that is on your Raspberry Pi Pico. So of course, it goes without saying, I should say that you should make sure your Raspberry Pi Pico is connected, and we are using Thonny. And down here, make sure that you have your Micropython Raspberry Pi Pico selected as your interpreter. So if you have that set, then you can hit the open button or save button to save to the Raspberry Pi Pico. I hit open to just show you that I already have this file. This SG90py is on my Pico, so I am free to use this. So we are going to, I've got a new file here. I've already named it as Servo Simple. It doesn't matter the name. We are going to just show you the code you need to write to make this servo move. So my goal is to just show you how to make it move to specific angles. So the first thing I'm going to do is going to import that library we just mentioned, SG90. So just say import SG90. And again, you have to make sure it's saved on your Pico before you can work with it. Next thing is I'm going to import the machine library, which is the standard Micropython library that allows you to access the GPIO pins. And before we do this, let me look at the pin layout. So you should be able to see the way things are connected. We have the Pico, oops, I've got this backwards. Let me switch this around. Well, actually, I do think it is correct. There it is. So you should notice that we have the red pin going from the V bus. So this should be our 5 volts out. We have the black pin or brown pin going to the ground. And then we have the yellow pin, which is the signal pin to control our servo, is going to GP15. So we're just powering it from the Pico using the V bus, and then we have it grounded, and then we're using GP15 to control that. So let's go back to the code, and now let's see what we're going to do. So first thing I'm going to do is I'm going to create a function called move, and this is going to take something that represents the servo, so kind of like the servo pin and an angle. Now you wouldn't have to do this, but it's just nice to put things in a function. And so what I need to first do is make sure that I get the duty cycle that I want based on the angle. And that is the whole point of this function here in this library. So I'm going to just copy that function name so I make sure I don't mistype it. So this duty cycle for angle, which is from our SG90 library, I'm going to use that. And in here, I just have to give it the angle. So like if I say, hey, I want to move to center, which would be 90 degrees. If angle passed in here is 90, then that would say, give me the duty cycle for 90 degrees. Then I would say servo dot duty U16. And then I give it the duty cycle. And this duty U16 is just part of the machine library. As we'll see here in a second, we're going to define the servo above, which comes from our machine library. So let's go ahead and do that. So to make it more clear, let's create our servo, and we will make our servo, it's going to be machine.pwm. So we're going to use the PWM library from, or PWM from machine. And in here, we have to give it the pin, oops, machine pin. And then we have to tell which pin we're going to use for PWM. So we're saying, hey, we want to use PWM out, so on pin 15. So now we've created this variable for our servo that is using PWM on pin 15. Now, another very important thing to do, and I forgot this sometimes, and it causes bad things to happen. We have to set the frequency of our PWM. So with PWM, it's pulse width modulation. You're pulsing little electrical signals, and the frequency or the hertz that you are sending those pulses is very important. Because if I go back to my spec sheet, I don't think it says on this one, but this other spec sheet does tell you that the pulse or the frequency is 50 hertz, okay, or which equals 20 milliseconds. So 50 hertz is 50 times a second, so 20 milliseconds. So if we go back to our code, that's what we're setting here. We're setting the frequency to be 50 hertz because that's what the servo is listening for. So the little board on the servo that's listening for those signals through pulse width modulation expects information at a frequency of 50 times a second. So we're setting that. All right, so here's the cool thing. With just that little bit of code, now we can actually start moving our servo. So we can actually call our move method, pass in our servo, and yes, technically, this would be at a global scope, and so you probably wouldn't have to pass it in, but I like to have my functions be clear about and pass in what they're working with. So the angle, let's center it first, okay? We're going to center it, and then before we move it. Let's actually import U time as well, so we can put a little pause in here between our movements. So I'm going to sleep milliseconds. Let's sleep for a second. And then we are going to move our servo again to, how about 0, which would be one far side. We are going to then sleep again for another second. And then we will move one more time to the other extreme, so 180. All right. So let's go ahead and run this and see what happens. And I did on the servo horn here, I used a black Sharpie and made it black so it's easier to see. Right. And there we go. Now, it looked like only 2 moves. Let me run it again. Well, because initially it was already centered, so you didn't see the first move to center it at 90. So let's run this again. You should see it now snap to center, then move 2 times. There we go. So since it stopped at 180, when this ran the second time, it moved it and centered it at 90. So let's try that one more time. There we go, centered, back and forth. All right. Now, of course, I could wrap this in a while true loop and just make it just keep going. So let's do that. Let's try this now. So we get it, see it keep moving back and forth. Oh, what did I do here? So this is perfect. Let's see what's going on. So we are, so the issue is the reason we're only seeing 2 moves is since I put this in a loop, it moves, it centers it, moves it to 90. Let me put a little comment beside this. So center, then we sleep, obvious. I won't comment the sleep. Yeah, and then to one extreme, and the camera, your angle would probably be the left and right. It doesn't really make sense. So so we're just going to move to the other extreme. So extreme means the full movement. These servos only go 180. So the most you can do is from 0 to 180. Okay. But what happens, so when I run this, just see what's going on again. So it looks like we're just going from center to one direction. And that is what we're doing. Because the way this code is written, and the way the while loop works, is we say center it, sleep for a second, then move to one extreme, then sleep for a second. Then we try to tell it to move to the other extreme, but there's no sleep after this. And so it immediately comes up here and says, no, center it. So we never see it move to 180. It's really just going 90, 0. And even though the command goes to say move to 180, before that can be executed, the command to say center it comes through. And so we're only seeing it bounce back and forth between 0 and 90 because this 180, there's no sleep time after that to allow it to actually move there. And so it's immediately getting the next signal or command to move to 90. So let's add a sleep after that. Now when we run this, make this a little bigger, we should see it do as we expect. So center, move one extreme, move the other extreme, center, move to one extreme, move to the other extreme, back and forth. All right, perfect. And that's as simple as it gets. Using this simple block of code, you can control, and obviously you could put any angle you want in here between 0 and 180. So I could say, instead of centering it, let's go to 42. So run that. So you can put any angle in here, and if you use your for loops, you can actually, slowly have it pan. And that is the challenge I give to you guys, is to rewrite this code and use a for loop to have it maybe center it and then pan one direction slowly 90 degrees, then recenter, pan the other direction 90 degrees, and then recenter, and just keep doing that over and over again. And again, I'll have links to the different files and articles for these text sheets in the description below. And again, if you really want to understand more about what this is doing, you can read all of these notes and these articles that I linked to in this library for the SG90. And that's all I have for you today.